Okay, so the last part of the review, you notice it kind of jumps around a little. Like that's section 3.5, that's 3.3, that one's chapter 1. So some of the stuff may be kind of mixed up a little bit. On the test, it's not going to say what section it is from in the book, right? So as far as you having to know like what section something's from, that's more so you could look it up in your guided notes. Right? But that won't help you for the test. All right, as we go through it, if there's one you didn't understand or something you want to write down, I would add it to your reference sheet, okay? Because now you can put the correct answer on these boxes. Yes? Yep. Okay, so question 1. It says, find the slope and y-intercept. How do you want the equation written to find the slope and y-intercept? There's a certain format it should already be in if it's not. Yep?
Y equals mx plus b.
Right, it's got to be like this. If it's not, your job, the first thing you have to do is get it like that.
How do you know it has to be like that?
Because that's called Slope-Intercept Form. It has to be in Slope-Intercept. Is our problem in Slope-Intercept?
No. Yes, it is.
Yes, there's nothing I need to move around. It's already y equals mx plus b. The m is which one of these two? What's your m? Yep, that's your slope. And the b? That's your y-intercept. So, because this one is already the way we need it, this one couldn't be any more like set up perfect. What's the slope here?
9.
Just the 9. If you put the x with it, I'd probably mark the slope wrong. All right, so slope, just put a number. But 9 is the right number. And what about the y-intercept? -8. Sign to the left always goes with it. Okay, so -8. Question like that, you'd either get 0 points, 1 point, or 2 points. Right? 2 points if you get both right, 1 if you get 1, 0 if you got both wrong.
Okay.
Yeah.
Did we find out what grade we got on midterms?
Yes, you will. I'll have it graded probably the next day. By the next day. Yep. Maybe even later that day because you guys take it early in the morning. So I'll probably have it the same day. Not during your class, but maybe afternoon. Okay, questions on slope and intercept. Number 2, it says evaluate. Remember, evaluate is just a big word that means plug in. So plug in the numbers -5, 0, and 6. So you have to do this problem 3 times. Each time, you're going to take that number and you're filling it in for the x spot. Okay? So let's do the first one. And you fill it in right here too. You fill it in both. So what's the first number they want me to fill in? -5. So off to the side. Remember, the way you pronounce that is h of -5. That's how you say that. And what it means is, if you plug -5 into formula h, you will get, and now we have to do it out, 3 times -5 minus 4. Whatever you get here is what I want to put on that line. Lucas?
What happens if you go if you get I know if you don't put the h of -5.
Well, this part would already be written on the test.
Oh, okay.
So you're going to have to fill in the 3 blanks. So this question would be worth 0, 1, 2, or 3 points. Okay, what's 3 times -5?
-15.
-15. And what's -15 minus 4?
-19.
-19. So if you plug -5 into the formula, you get -19. Okay, let's do 0. H of 0 equals, you know what? I'm just going to do it on the same line. Equals 3 times 0 minus 4. But you have to simplify it. What's 3 times 0?
0.
And 0 minus 4? -4.
I have a question.
And that's the second one.
On all the way to the left, would you multiply the h by -5?
No, this means h of -5. What that means is if you plug -5 into that formula, this is the result you get. So there's nothing to do on the left. Yep, nothing you have to do. Okay, what do they want me to plug in the last one?
6.
6. So it's going to be 3 times 6 minus 4. What do you do first? 3 times 6 or 6 minus 4? 3 times 6, which is how much? 18. And 18 minus 4? 14. Perfect. So that's what you're doing in number 2. Okay. Any questions on that one?
How did you get the -4 on the left side?
The -4?
Yeah.
The -4 is part of the original problem.
Yeah, but how did it get to the left?
How did it
Like
get?
on the left side of the equal.
So all I did was I basically just took this number, put it in right there. That part's already done for you. And then put it in right there. So I put the 0 in for x, and I just wrote 3 times 0 minus 4. So I just copied this down each time, but changed the x to the number they said to. Any other questions on that? So that's all you got to do, just copy down what's in the box, but change the x each time. Change it to a -5, a 0, and a 6. Okay, okay, let's look at this one. So a word problem. It says you want to put up a fence around your rectangular backyard. Okay? And they tell you a couple things. The length of your backyard is 69 feet, and the area of your backyard is 2,070 square feet. Eventually, we're going to use the fact that the fencing costs $10 a foot, but you don't need that for part A. That will be for part B when you figure out how much it costs to put a fence up. Okay, first question they ask is, what is the width of your backyard? All right, so what shape are we dealing with here?
Rectangle.
It's a rectangle. And then it says they give you the area, and they give you the length. So we're going to need to plug those numbers into a formula. So the first thing we have to do is write down our formula. So the shape is a rectangle, and the problem is about area. So what's the formula for area of a rectangle? Oh, Maya? Do you have a formula for area of a rectangle?
No.
Like if you were going to put tile down in a house on a floor, and the guy at the store said, how many, what's the square footage of your room? To ask you how much tile you needed. How would you find this, like the square footage of your floor?
Like 70, 60.
Not quite, yeah.
Wouldn't it be a length times width?
It's length times width. Okay. So the area is the length times width. Now, fill in the numbers that they gave us. What did they tell me the area was?
2070.
2070. So I got that. What did they tell me the length was? 69. What did they tell me the width was?
Put a variable.
The variable. We don't know that. That's the question. What's the width? So now we just have to get W by itself. Well, you could call it X, whatever you want to call it. So how do you get the W by itself? Yeah. Yep. You're going to divide each side by the number in front of the W. That's gone. Now, we're going to need a calculator for that. I think this is probably the only one you needed a calculator for today. So tomorrow I'll make sure you have those out. So 2070 divided by 69 is 30. And what did I just find? That's the what?
Width.
The width, and it's in feet. So the answer is 30 feet. Not just 30, but 30 feet. Questions on how we got the width of 30? All right, now we got to figure out how much it costs to put a fence up in the backyard. What's the shape of the backyard again?
Rectangle.
It's a rectangle. So here's the rectangle. That represents our backyard. How long is the backyard?
69 feet.
Yep, 69 feet. How wide is the backyard? That's what we just figured out. Now, what about the right side of the backyard?
30.
It's also 30 because it's a rectangle. and the bottom of the backyard. So what do we do with those 4 numbers to figure out how much fence we need? Add them together. You're going to put 30 feet of fence here, plus 69 feet here, plus another 30 feet, plus another 69 feet. So add them all up, and that tells you how much fence you're going to need. So we've got 69 times 2, plus 30, plus 30. So that's a total of 198 feet of fence. So total fence is 198 feet. Now, is that what they wanted to know?
No.
No, they want to know how much it would cost to put up 198 feet. So we got 198 feet, and it costs $10 for every foot of fence. So what do we have to do now? Yeah. Multiply. Yeah. So the cost is going to be, how much fencing do you need? You need 198 feet times $10 a foot. And if we multiply that out, I don't think we'll need a calculator. What does that come out to?
1,980.
$1,980. $1,980 to put up a fence. Okay. Any questions on that one? And again, that's going to be on YouTube later this morning, so if you need to go back and check it, but you didn't get to copy it, it'll be online, just like yesterday's video is also online. Okay, number 4. Okay, a couple things here that you have to know. You can't do everything with just one thing. It says, which of the following graphs are functions? Okay, in order for something to be a function, okay, one thing that can happen is it passes the vertical line test. Okay, that will only work if you have a picture. Okay, it has to pass the vertical line test. The second thing you can check for, each x value has one y value. That'll work if you're given a table, a diagram with arrows, or a set of coordinates. Okay, so we need to use both of those. All right. C and E are the only ones that you have pictures for. So in order to pass the vertical line test, that means you take a vertical line and it only hits your graph once. In graph C, does it only hit once?
No.
No. So that is not a function. Right? The question is, which ones are functions? So that one is no. Let's look at E. If I put a vertical line, does it ever hit 2 dots at the same time? No. No matter where I put it, it never hits 2 dots. So yes, that one is good. If you had a dot like that, would a vertical line hit the same? Could it hit 2 dots now? Yeah, that would be no good. But that's okay. All right. Now, for A, B, and D, make sure each x has exactly one y. All right. So let's look at A. The number -8 goes to what number? 4. Any other number?
No.
Nope, that's okay then. How about -4? What number does that go to? 6. Any other number? Nope, that's okay. How about the number 4?
7 and 8.
That's a problem. Each x value has to go to 1. I forgot the word. Y value. That's important. Each x value has 1 y value. That is not true in number 4. The x value of 4 has a y value of 7 and 8. No good. All right. Now we can do the same thing with B. -8 goes to what number? 14. Anything else?
No.
Then it's fine. -4 goes to what number?
13.
Perfect. 3?
12.
5?
7.
So each x value only goes to 1 y value. That one is okay. Here's something that would not be okay. if you put -8, 3. Now you're saying -8 goes to 14 and -8 goes to 3. No. Now you've made -8 go to 2 different spots. That would be no good. Now let's look at D. -3 goes to what?
-12.
Any other -3s in the x's?
No.
Nope. How about -1?
Okay.
Yep. Do you see it anywhere else? Nope. In fact, each x value only happens one time. So that is a function. Here's how you could make it not a function. Let's do 3, 5. If I added that in, why would that be not a function now?
Because it's already an x value 3.
Yeah, we already said 3 goes to 12. Now you're telling me 3 also goes to 5. You can't do that, right? So that would be not a function. Okay, so that's how you tell if something is a function. A problem like this on the test, it'll probably be worth, it'll probably be worth 1 or 2 points. So if you get you could get partial credit if you get some of it.
I forgot how many questions are on.
About 30. 30 questions. Yep. Okay. Number 5. Which of the following represent linear functions? This is a linear function. Y equals mx plus b. Okay? Anything that could be rearranged to look like that, or just look like that. Like y equals a number, y equals 2, y equals 3. If your equation has any other funny stuff in it, it's not linear. Okay? So what we're going to do is look at these equations and look for stuff that we normally don't have and cross that out. Okay? So how about A? Do you think that would be linear? Yes or no?
Yes.
No, why not? It has bars in it. When we graph straight lines, they're not supposed to have these bars in them. It's supposed to look like this. Is there any bars in what I wrote there?
No.
No? Is there any bars in what I wrote there?
Wait,
No.
so if it's mx plus b, then it's linear?
Yep. Or if it can be rewritten so it's in y equals mx plus b. Okay? If you could rearrange it so that it would be. Okay? We did that when we had like point slope. We took something in point slope and we used the distributive property to fix it. How about B? Do you think that would be linear? Yes or no? Yes. Because you could get y by itself there. And it would look just like this. If you minus 7x from each side and then divide by -4, you could get y by itself. So this is linear. Okay, that one is linear. How about C?
No.
No, what's weird about C that we normally never do?
It's a fraction.
And what about the
There's no
fraction?
plus over it.
It's over, right? We never have an x in the bottom of a fraction. You can have a fraction, like this is okay. Like something like that. 2/3 would be your slope. But you cannot have an x in the bottom of a fraction. That's weird, right? There's no x's in the bottom of fractions right there. How about D? Would that be linear, yes or no?
Yeah. Yeah. No. Yeah.
No, why?
Because it has a exponent.
Has an exponent.
Oh no,
Okay.
that's good. That's good.
No good. You can't have exponents.
Oh.
But can
Right?
you fix that exponent and multiply and whatever to make it point slope?
No, because an exponent is not multiplication.
Oh.
No, an exponent is a power.
Oh.
That's different than having like a distributive property. Okay? Here's an example. Let me show you what happens if you don't have an exponent and you draw that. Perfect. Nice straight line. Watch what happens if you add an exponent to that. I'm going to add a 2. Right? That's a 5, but I'm going to do a 2. If I add a 2, is it a straight line anymore?
Oh no.
No. Adding an exponent causes it to bend. That's not a straight line. How about E? Yes. This is like point slope. If you distributed the 5 and minus the 8, you could make it look just like y equals mx plus b. So E is okay. How about F?
No. Yes. Yes.
Yes. Y equals a number. That's exactly what F is. Right? So things you don't want to have. If you want it to be linear, no x's in the bottom. No absolute value bars. No exponents on the x. You can't have any of those things. So if you know those three, you should be good.
What was the last one you just said?
So no x's in the bottom, no absolute value bars, no exponents. Okay, so this one, I put up a chart so you guys could see it. It's in section, I think it was 3.6. There's your formula, okay? That part's not really important. What's important is this part. What they're telling you is if you put a number in front of f of x, they want to know what that number would do. So this is number in front of f of x. Let's pull up our chart. Okay. Looking at, let me make that a little bigger. Looking at all the boxes, there's 8 boxes. Does anybody see, let's call it like box 1, 2, 3, 4, 5, 6, 7, 8. One of those boxes is exactly what we have on the other page. So remember, we had 5 and then f of x next to it. Anyone see which box that is?
Box 1.
Yeah, it's box 1. You have a number times f of x. Right? If you had plus, that would be something different. If you had minus, that's something different. But this is a number times f of x. Now, how come it's not box 5? That's also a number times x. But what's the difference between box 1 and box 5?
Because the number's not in front of that.
Right, exactly. It's where the number is. Okay? Box 1 is what you guys have right there. This is what box 5 would look like. Number times x. The number is inside the parentheses. Okay, so if we go back, number times x. The number is right next to the x. That's different. We're not doing that. So when you have a number in front, what kind of transformation is that? And it says to describe it by saying vertical stretch by factor of, and then you just say your number. So for this one, this is what you would write. Vertical stretch by factor of how much? 5, exactly.
But wait, how do you get the? How do you know if it's vertical or horizontal?
So you have to look at what they give you and match up what's in that box with one of those 8 boxes there. Okay? Like if they did something like, let me show you another example. Let's say they did f of x minus 2. I would say, okay, I've got a minus, a 2, and it's on the end. So now I go to my chart. Look for where a minus, boom, right there. F of x minus 2. That would be box 3. That means it's a shift down 3 units. So you got to look at what they give you and match it up with one of those 8 boxes. And then write the thing that's in quotes. Shift up, shift down, reflect, okay? But it'll always match up with one of those 8 boxes. Okay, second to last one. Use intercepts to graph the equation. Okay, so to graph with intercepts, you have to plug in a number. Does anybody remember what number you plug in to find an intercept? Yes, you plug in 0, right? To find the x-intercept, this is probably important to know. Plug in 0 for y. To find the y-intercept, plug in 0 for x. And no, I didn't write that backwards. That's how you do it. 0 for y gives you the x-intercept. 0 for x gives you the y-intercept. So let's do the x-intercept first. Plug in 0 for y. All right, look at your formula. Put a 0 right there. I'm going to do this right down here. X minus 0 equals -1. You can add 0 to both sides. You don't even really have to. I mean, that cancels it out. What's -1 plus 0? That's your x-intercept. And they want you to graph it. Well, it's going to cross the x-axis right there. -1. Right? We don't use the x-intercept as much. We use the y-intercept a lot. That's the next one we're going to find. All right, to find the y-intercept, what number do I plug in?
0.
And where do I plug it in? Plug it in right here. Plug in 0 for x. 0 minus y equals -1. Okay, you could minus 0, that doesn't even really do anything. -y equals -1. So if -y equals -1, what's y?
Positive 1.
Positive 1. Just divide each side by -1. So y is positive 1. That's on the y-axis. So positive is which way?
Right. Oh.
Y-axis.
Oh.
Up. So there's your y-intercept. That's enough information to draw your line. Just go like this. All you have to do is find those 2 dots and then just put a line straight through them. All right, 5 minutes. We should have enough time. Last question. So, the last question gives you an equation that says the number of eggs you have left in the carton after making B breakfast sandwiches is given by this formula. Okay? When they give you a formula like that, this letter is always your dependent. Okay? The letter they put by itself is usually the dependent. The letter they put on the right,
So
independent.
the dependent is the y.
Yep, exactly. Dependent is your y, even though they didn't really use y here. Independent is your x, even though they didn't use x here. They used n and b. I guess n for number of eggs and b for breakfast sandwiches. So, independent, they use the letter b. Dependent should be y, but they didn't use y. They used n. Now, it says the domain is 1, 2, 3, 4. Okay? Which one of these is domain? The b or the n? The b, yes. Independent means domain. Just another word for domain. Dependent is range. So the domain is 1, 2, 3, 4. That's b. So what we want to do is take our formula, -2b plus 24, and plug each one of these numbers in one at a time. It's like what you did in this problem right here. You're going to plug each number in one at a time, except instead of 3 of them, you have 4 of them, right? So what's the first one they want me to plug in? 1. What's -2 times 1? Plus 24? $22. So in your range, that's the first number. If you make 1 breakfast sandwich, you'll have 22. Now you have to plug in each one to get the other three. It'll be 20, 18, and 16.